Hello everyone, I'm Jivika Kancherla and I'll be explaining you guys the solving of 7 questions in homework 9 of the course Probability and Stochastic Processes. Before we look at the solving, let's have a quick look at the question. So the 7th question states, show that the random telegraph signal is a strict sense stationary process. Now let's look at the solving. So let us consider y of t to be a random telegraphic signal. That is, probability of a is equal to minus 1 is equal to probability of a is equal to 1, which is equal to 1 by 2. Now y of t can be written as a into x of t because random variable independence. Now we can expand y of t as a joint probability function as probability of y of t n is equal to 1, probability of y of t n minus 1 is equal to 1, and so on till probability of y of t1 is equal to 1. Now this joint probability function can be represented as the probability of the as the conditional probability times the probability of the condition. That is, the joint probability will be written as conditional probability times the probability of the condition. That is, p of ytn is equal to 1, p of ytn minus 1 equals to 1, and so on till yt1 equals to 1 can be written as probability of ytn is equal to 1 given ytn minus 1 is equal to 1, and so on till yt1 is equal to 1 times the condition. That is, all of this, that is probability of ytn minus 1 is equal to 1, ytn minus 2 is equal to 1, yt1 is equal to 1. Now from here to here, similarly we will be expanding this probability joint function as the probability of as the conditional probability times the probability of the condition, and so on we will continue. Therefore we are trying to show that probability of ytn is equal to yn, ytn minus 1 is equal to yn minus 1, and so on, yt1 is equal to y1, which will be equal to probability of ytn plus e, which is equal to yn, and so on, yt1 plus e is equal to yn. That is for any value of n and for any value of t1 to tn and so on. Now the probability of ytn is equal to 1, ytn minus 1 is equal to so on till yt1 is equal to 1 is equal to probability of yt1 is equal to 1 given ytn minus 1 into probability of ytn minus 1 equals to 1 given ytn minus 2 is equal to 1, and so on till probability of yt1 is equal to 1. That is, this will be the function of tn and tn minus 1. This will be the function of tn minus 2 and tn minus 1, and so on. This will be the function of t. Now we can clearly see that these values are dependent on n. So that is, if we consider this to be a sample telegraphic signal, then it can be represented as shown below. That is, you will get box signals, box telegraphic signals, and this point will be tn minus 1, this will be tn. Therefore, we can write probability of y of tn is equal to 1 given y of tn minus 1 is equal to 1 is equal to e power minus lambda into tn minus of tn minus 1 into cos h lambda into tn minus 1. Let us consider this to be equation 3. We can see that each term in equation 2 is of the form of equation 3. Now if we replace tn with tn plus e, we can see that all the epsilons get cancelled at each other. Therefore, the probability of ytn is equal to yn, ytn minus 1 is equal to yn minus 1, and so on till yt1 is equal to y1 will be equal to probability of ytn plus e equals to yn, ytn minus 1 is equal to ytn minus 1 plus e is equal to yn minus n, so on till yt1 plus e is equal to y1. Therefore, it will be a strict sense stationary. Hence, this is the solving of the 7th question.